Alright, so here's my CNC table I started about a year ago. Hadn't had much time to work on it, just when I get time. So this is the control center, I call it. It's made out of a Craftsman roll-around toolbox. I have a shelf on the side for the CPU. I made this little bracket up the side to hold the monitor. The bottom here has 4 power supplies, 4 drivers for the axis. It has a breakout board and the little red light back there is a solenoid, I guess, to turn on your tool, whether it be a plasma cutter or a router spindle. I need to mount that somewhere a little better. I still have to put my limit switches, wire them into the breakout board. That'll be my next task, in putting the switches on the table itself. I do have these shelves or drawers that I can still use for whatnot. On the back here, I have a power strip with a 5-volt power supply for the breakout board. The one hanging there is a 12-volt power supply. I don't think I'm going to need it. I just kind of stuck it up there. I think I'm going to pull it back out. Here at the bottom, I used 4-pin trailer connectors to wire the motors. That way I can disconnect those if I want to store everything. Then I have the parallel port that comes out of the breakout board and wires into the back of the CPU. We're using Mach 3 software. I've got it tuned for distance. If I tell it to go an inch, it'll go an inch. Still have some a learning curve here. We've got to understand how to make the Z-axis plunge and touch off of the material and then offset, and that'll be done with the limit switch, and to get your correct height of your plasma cutter, so it'll cut a really good cut. The table itself, I use NEMA 34 motors. There's 2 for my Y-axis, I'm calling it here. 1 for the X, and then I used a NEMA 24 for the Z. Originally I was just going to use one motor on the Y-axis, but I noticed that I had some racking of the gantry, so we had to go with 2 motors and 2 screws so it would run across the table without racking, because it is so long, so big, so heavy. It's made out of 2.5 by 2.5 inch quarter wall tubing, and I had a real good buddy of mine. We designed and cut all these brackets. Thank you, Mike. He's really helped me a lot on getting the bracketry cut. We had to go back and make a couple of corrections here and there, but it's worked out pretty good. We're using China screws and China linear rails and bearings. I will tell you, they're not perfect. The bolt patterns on the bearings are slightly off from one to the other, but they do work. They seem to roll really smooth. I bought this cable track in, I think, 40-inch pieces. I had to add 2 together for each axis. I've got to go in on this x-axis and add another brace. You can see here this one droops just a little bit right here. I was thinking I wouldn't need it, that it would hold itself up, but it does have a little droop, and those are just made, you can see there. And I have 3 here. I think if I put one more right here, that's gonna do the job. I was trying to not use one so when it come across, that bracket wouldn't be sticking out on its own, but I don't believe that's going to be the case here. On the y-axis, I don't think I'll have to have an extra one because it does pull up so high that it doesn't cause any droop. Let's see what else on the table. I still have to wire in the limit switches, make some brackets for them. I'm going to try to put limit switches at each end of both sides of the y-axis so I can use those to square the gantry. If it hits one limit switch, doesn't hit the other, you can tune one motor to come in and hit the switch. And then I'll use 2 on the x-axis, and that will make sure that I don't go to the extreme limits and tear anything up on any of the axis. And then we'll use a limit switch for touch off on the material. The table is still just tack welded in spots. I want to make sure everything works, and then I'm going to tear it back down, weld all of our seams. Everything is just tack welded in spots. Like I say, I want to make sure everything works as it should before I tear it back down. I use 16-4 flexible cable to run to all the motors. This one I ran up through the tubing to come out to this motor to kind of hide it. I still have to put some slats in for the material. We want to do a water tub in it eventually. You know, time is a factor. Let's see, what else do we need to do here? Like I say, I still have to make the mounts here for the tools on our plate. I know everything on this table probably seems a little bit overkill, I would say. But I wanted to be able to stick some thick material on here and not have any issues with, over time, the table legs coming out or bending or whatnot. So I just built it a little probably heavier than I needed to. Like I said, we're going to tear it back down, paint it, clean all of the welds, weld up all the connection points on the gantry, the mounts for the motors. This has been a let me tell you, a chore of trying to teach yourself when you've never had any experience with CNC, and you know, learning the software, which I still have a lot to learn. Learning how the motors work, how to tune them, how to get the distances right. We were going to try to tap every hole for these guide rails, but we wound up drilling completely through. You can see here there are holes that correspond to the bolt hole on the other side for this linear rail. There's some up underneath here for the top linear rail, and we drilled all the way through so we could use nuts. I don't know why, I just felt more comfortable using a bolt and nut for these. We wound up center punching them, and then we used the old trusty mag drill here to stick on there and drill every hole. That took quite a while. We had to do both rails on the Y, both rails on the X. So it took a lot of drilling completely through both sides, and then going back and drilling a bigger hole on the bottom where we could get a nut in there and a socket to tighten them up. Of course, I only have a few in right now just to hold it until we tear it back down. Then we'll put a nut and bolt in every hole. Right now I've got it running at about 105 inches a minute, which seems to be pretty good. Every now and then I'll have an error out. I'm not sure what it is. Some people on the internet have told me that it's sometimes the motors can skip, some people have called it. I think with these stepper motors that you try to run them too fast without tuning everything correctly, that it gets kind of, I would say, out of time. It sounds like it's moving, but it's not. At first I thought it was the bearings binding, but it's not. It's just the motors stop because they are overclocked, out of time, and there's a lot of settings on Mach 3 to get that working right. And at first I only had it at about 70 inches a minute. Now I've got it to 105. It just takes a little time to tune it. I'm really not a pro at motor science, you would say. So I'll run a little demo of it moving here. If I run both the X and Y, run them across, and that's running at actually 144 inches a minute. Now I'll run it back home. I've got the running it when it goes home at about 70%, so it's kind of slower, but you can watch it run right back home. You can see here, screws moving. And it will move right back. So you can look here, and I have this piece of wire, and it is right here on 1. So I can calibrate going in here on the settings, and I can set the steps. So I'm going to try on the y-axis. I'm going to tell it to go 10 inches. Now we'll walk over here and we can watch it move. It started on 1, and there it is, right on 11. I can tell it to go back home, which will be where the wire was on the 1, and it will come back and stop right on the 1. So at 10 inches, it seems to be right on. I do need to get a dial indicator and try to move it like 1 inch and see if I get it, you know, into the thousandths of accuracy. Guys, pardon my shop. I have so many projects going. I've got a boat motor down there that I've got to put in for a friend that's in the box there under the shirt. I've got all my parts here that I've been working on the table. I got a friend of mine's Jeep parts here on the floor. We got to install my sign shop. I've got aluminum sheeting in here I've been cutting. I got a small shop and not enough and too many projects. So just pardon that. I'm just trying to get this machine in here, give some of you guys a little insight. Yeah, I have a few welds that aren't too good on here. I had bought a new welder, and in the process of building this, I was trying to learn the new welder also. I think I've got it tuned in now. That weld right there is pretty ugly, so bear with that, but they are getting a little better. Here's one down here, if I can get it down here. It looks pretty good. I ran those were just a day ago, and it doesn't look too shabby. I know some of my welding buddies probably would say not so good. You know, I remember welding this one, I forgot to turn the gas on, so I had to go back over it. So I'll clean it up and it'll look fine, but I promise you it'll hold. These motors here, like I say, I just have tacks on them, so I'm gonna go back and put an inch of weld here and there, and so they'll stay and we'll have no issues there. I really don't think they have a lot of force on them, but it works. This side I did finish welding, and that's about all I'm going to put on there. And I have some on the sides too, on each side.